The Oracle Database Property Graph now lets you write PGQL graph queries in SQLcl, a command line interface. And what that lets you do is issue PGQL queries on graphs from SQLcl. So these are graphs that are stored and represented in the database, and you can issue property graph query language statements against those. So what this demo shows that functionality, how to use it. So the first step is to create tables into which we are going to load some data. The data will come from CSV files, one containing bank account information, another containing transfers or transactions between those accounts. The table for accounts will come from a CSV file called bankaccounts.csv. It has 1,000 rows. And the data for the transactions will be from a CSV called banktransactions.csv, which has 5,001 rows. Once those are loaded, we can then create a graph representation and query the graph. So we've loaded the accounts, we've loaded the transactions, and the next step is to create the graph. In order to do that, we first have to enable the PGQL mode. So far we were issuing SQL and SQLcl related commands. So you turn on the PGQL mode so that you can then issue the PGQL statements, whether that's DDL or whether that's queries. So we've turned that on, and now we can issue the create property graph statement. This is going to create a graph representation of the accounts and the transactions. The accounts will become the vertices, the edges will be the transactions, from an account to an account, and the amount that was transferred. So we created the graph. Let's just validate that the graph was created correctly. One way to do that is to check the number of vertices and the number of edges and see that they match up. And once we've done that, we can then do additional queries. For example, find all accounts or the number of circular payment chains. Let's say we're investigating suspicious accounts or possibly fraudulent transactions. One of the ways in which that's done is to look for circular chains, which means a transaction that originates from an account, goes to some intermediate accounts, and then ends back up at that account. So we've validated that the graph is created correctly. 1,000 accounts, 5,001 edges. Let's look at the number of circular payment chains with 3 hops. So there are 131 of them. And then the same circular payment chains with 4 hops. There are 530 of those. And the last step is let's just count which are the accounts that have the most number of deposits made into them. And that is the demo of PGQL in SQLcl.